In this video, I'm going to go over the answers to one of our homeworks on Digital Day 5, where we had to go over or use key features of parabolas. So the first thing I'm going to look at is going to be a parabola that is graphed for us, and we have to answer different questions regarding the domain and range and the vertex. So first, the domain is going to answer the questions about what x values are being used. And in this case, it's a parabola, which is a polynomial, and the domain is going to be all real numbers. So we're just going to write that down. All real numbers. Then we have to answer the question about the range. What is the range that's being used, or the range of values? And the range has to do with y values. And we notice that the lowest y value that we reach is going to be 4. So I'm going to write y in 4. And it's the lowest, so that means we're staying above it, or we can be equal to. So our range is going to be y is greater than or equal to 4. The vertex is going to be this point right here, and it has coordinates of 1, 4. A parabola is concave up because it's facing up, and it has a minimum value, or the lowest value, right? And that minimum value is 4. It is essentially the y value of your vertex. We now then are going to look at the y-intercept, and the y-intercept is this point right here, and we're going to list it as 0, 5. We don't have any x-intercepts in this particular problem, so we're just going to say none, because our parabola does not cross the x-axis at all. The axis of symmetry is a vertical line that cuts through our parabola smack in the middle, where the right side and the left side are going to be identical. So the axis of symmetry is a vertical line, so we're going to start our equation with x equals, and the x value is x equals 1. All right, so the second question, we are looking at a different parabola. Our domain is still going to be all real numbers, so all real numbers. Our range is going to be all of the y values that are below or equal to 2. Our vertex is this point right here, which is the turning point, or the highest point in this case. So negative 2, 2 would be the coordinates. Our parabola is facing down, and our parabola has a maximum value. The maximum value is 2. Our y-intercept is right here, and it is 0, negative 6. Our x-intercepts are the 2 points where we cross the x-axis, so negative 3, 0, and negative 1, 0. So they are right here. So these 2 points where our parabola crosses the x-axis. The axis of symmetry, again, is a vertical line that passes through the middle of our parabola. It will always pass through the vertex. So in this case, it is going to have the equation of x equals negative 2. So then on the second page, we're going to switch things up a little bit. So here, you're going to draw your own parabola that satisfies the requirements. So let's take a look. Our axis of symmetry is x equals 2. We have to have one x-intercept. And for that to happen, the vertex has to be on the x-axis. So you have a couple options. So I'm going to draw my parabola concave down. You can have your parabola concave up. But what's important is that your vertex is on the x-axis. Okay. I have to have for number 4, a maximum at the origin. So here's my origin. And the maximum means it's the highest point. So this is going to be what I draw. In number 5, the range of my parabola has to be less than or equal to 2. So you can really draw your parabola anywhere as long as it stays underneath 2 and your vertex has the y coordinate of 2. Right? Essentially, sort of this is the highest where you can be. Right, so for number 6, our parabola has to have no zeros, which means it has to be floating above the x-axis or below, and our axis of symmetry has to be the y-axis. So something like this would work really well for us. And in number 7, a parabola has to be concave up and it has to have 2 zeros. You have lots of different options. I'm just going to draw something like this. It is concave up and we cross our x-axis at 2 different places. In number 8, our axis of symmetry is going to be -3. And our y-intercept has to be at the origin. So what's going to be important is for us to use the symmetry and make sure that if the origin is on our graph, -3, 0 is also on our graph. So that concludes the work for